Here's what's going to happen for today. Okay, I'm just going to wrap up the rest of practical electricity. Okay, we will start magnetism next week. Okay, for now, I just want to finish this. Then I want to give you guys an MCQ, full MCQ set, 40 questions. Okay, and then you'll give me, I will mark, and I'll give you guys next week. Can? Can, Okay, come, let's go. Okay, so first, if you all need a recap on practical electricity, okay, I don't think it is super challenging, but okay, I will go through a short recap nonetheless. Okay, I will just go through very quickly, okay? Okay, our main focus, okay, our 4 equations. Okay, I told you guys how to derive those equations. Okay, through over here, everybody here should have written it down. Okay, then we talked about how you will use your I square R in a series circuit because current is constant versus V square over R in a parallel circuit because your voltage doesn't change. Fair? Okay. Then we brought in brightness because brightness is the main reason why we are even focusing on power in the first place. We talked about the rating of appliances, okay, where it's an optimal value that you should be operating at. And then we will realize that, hey, your resistance is the first value that we will obtain because he is the one that does not change. Agreement so far? Okay. Then the main focus of today's lesson, okay, we went through cost of electrical energy last week already. Okay, your kilowatt hour, okay, price per kilowatt hour, heating effect of current, blah, blah, blah. Okay, electrical hazards, you have 3 main problems. Okay, your damaged insulation, okay, you have your overheating, as well as water. Okay, the fact that you have tap water that contains ions means obviously it's not in his capacity as a pure covalent compound anymore, which means you can conduct electricity and then you can get electrocuted. Gets? Okay? Then, okay, safety measures, you have your 3 different wires, all different color. Okay, remember live wire brown, neutral wire blue, and then the earth wire obviously will be the green one. Okay, all of them have their specific purposes. The neutral wire is by far the most useless one. Okay, his only purpose is to close the circuit. Yep. Okay, live wire is to provide the energy to your appliance. Okay, and then your earth wire is just there in the case of a fault. Okay, in the case of a fault, you will have current flowing through your earth wire because it provides a path of low resistance. Yep. Can Jonas, okay? Okay, then you have double insulation. If let's say you don't have the earth wire, okay, we will make use of double insulation because if you have multiple insulation levels, then even though you touch over here, actually it's not an issue because your charges will never be able to move throughout your casing. It's an insulator, cannot conduct electricity. Okay? Then we have the fuse and the circuit breaker which serves to protect the appliance. Okay, your fuse will melt if excessive current flows through. Okay, your circuit breaker breaks if excessive current goes through. I will not touch on this just yet. Okay, this one is the electromagnetism. 2 weeks from now. Can? Good enough recap? Okay, now, with that being said, okay, I will just go through maybe 1 or 2 questions from electrical hazard and then I throw to you already. And then you all just continue all the way. Okay? I don't want to spend too much time on practical electricity anymore. Okay, I think it's majority of it is content. Okay, practice-wise, there's not much that you can gain from this. Okay, so just do as much as you can. And then about 1 hour mark, okay, we are going to start the MCQ set. Okay? Alright, question 12. Current of 4 amperes flows through the live wire. Okay, which of the following statements is true? Does this same current flow through the neutral wire? Jovia? Does Really No Okay, remember, okay, it's functioning normally, okay, in other words, no fault. If there's no fault, okay, then the earth wire should have 0 current. Okay, the neutral wire is the one that completes your circuit. He is the one that obtains your current. Okay, Susham, does your neutral wire have any voltage at this point? No, Okay, neutral wire, he just got current. Okay, have current. Okay, but no voltage. Easy? Easy. Next. Question 13. Okay, which row shows the correct color code for wiring an electrical appliance? You know me? Easy one. A. Oh, good. Okay, live wire is brown, earth wire green, yellow, and then neutral wire is blue. Any questions? If not, okay, I'm just going to select a couple of questions that I want you guys to do. Okay, 14, must do. 15, 16. Okay, 17. Okay, just do all of your MCQs first. 18 is the next one. I'm not going to bother about 19. Okay, I want you guys to do 20. Everybody following so far? Okay, so far we just skip 19 only, okay? 22 and 23. We are going to skip 24. Okay, I want you guys to do 25. Okay, and then from that point is all the integrated questions. Okay, question 26, question 27. Okay, 28 we will do if we have time. Okay? Okay, so if you guys need a recap, okay, 26, 27, okay, we are skipping 24, we are skipping 21, and we are skipping 19. You guys have until 5:35. Yes. Why? Finish it. Simple bell. Was I really tough? Why so big? No, you can't. No, you can't. Yeah, that's it. I bet it's 1 minute. Okay, everyone shut the fuck up.
Yay!
Everybody except for Jared says this. This shit fucking good, no joke.
Oh, yeah, you're right, bro.
What? Hello? Alright, fuck you over there. What? What's my favorite flavor? Take a pass around. Not as many as you want, what the fuck. Just take like a good amount. Okay, so legitimately speaking, okay, everybody except for Jared says this.
That's why I say the last is
Let's see the powder.
again it's so
Oh wait, over here.
you don't see all the people yesterday.
Oh, there's that community thing. Wow.
Guys, oh my god, big and fast. My god.
No, we have a t-shirt one to collect.
Wow, they were knocking it down.
Oh man.
Oh, this
Faster. Just take it and pop it in. It's fucking good. Pass them that box. Yeah, take tissue. Don't drop all your shit. Not joking. Don't drop your sugar and whatever nonsense. Okay. Which one you take? The matcha one is shit, bro. What the? Who takes matcha? What the fuck?
We all the ones as well.
Go. Not bad. You one person holding a box. Wait. Which one you take? They are very cold. Oh, sorry, aircon cannot control one. This one's a more control one. Okay, come. Everyone. Okay, let's get to question 14. Shh, and let's start lesson proper, yeah? Okay, from this point onwards, okay, I really want to go fast. Okay, I don't want to waste time like having to like tell people to shut up or whatever. Okay, so just listen up. If you have problems, you let me know. Okay? What? Just put it there first. Okay. Yeah, I know. Okay. Diagram shows an electric bulb of 1500 watts connected to 240 volt supply. What is the current when you're working normally? If you're working normally, Pawan, got current through earth wire? If you working normally, got current through earth wire? Don't have, Got current through neutral wire? Have or not? Have, Okay, we have our answer already. Any problem? Good. Question 15. C. The earth wire indeed protects the person. Question 16. What? D for dog. Do you guys agree? Anyone does not agree? Good. Question 17. 1.25. What's the fuse rating? Can it be 5? Cannot be the normal current lah. What the fuck? A bit stupid. Okay? B for boy. Question 18. Owen. Fuck. Answer for what? 17 is B. For bitch, can you listen? 18 is what? C. I agree. Problem? Can.
17 is what? Yeah,
Fuck, man. Okay. Go through this one. Okay, so you got 110 volts, right? Okay, firstly, F1, can you agree that F1 confirm will melt? He is the collective sum of all of your different currents, right? Okay, so this fella confirm fuck off one, okay? Then, what we need to do now is actually to just compare the current flowing through all of these. Okay, so the current flowing through this guy is how much? Jonas? 110 volts, 20 ohms. Minus 20. You have 110 volts flowing through 20 ohms of resistance. What's your current? Huh? Ratio of V over R ma? Your calculator? What's the current you got? What's the equation? The equation is V equals to I times R. If your voltage is 110 volts with a resistance of 20 ohms, what's your current?
5.9.
I agree, which is more than 5, right? So this fella melt lah. Okay, if you got any other answer, you can go ahead and calculate the current through this one as well. Okay, then you plus 5.5. You'll find that it's still less than 10. So it's okay. Can? We skip question 19. Question 20. Kieran? C. Do you guys agree? Sichang? Can I explain? Yeah. Okay, so your fuse is there, okay, to protect the appliance, correct or not? From excessive current. Okay, so what's happening right now is, okay, when it's switched on, the fuse immediately blows, means the current is too high. Okay, your current is right now, okay, is too high. So if this student go and replace it with a steel paper clip, which obviously will not melt like the fuse, then you are playing with fire ma, because I'm letting the current climb very high. Because your paper clip is not going to melt, right? Okay, and if I'm going to let it climb very high, then there's a fire risk lah, of course. Can? Problem? Problem? No? No? Good. 22. Zara? B for boy. Cable contains a wire connected to the earth pin. Okay. What danger can be prevented? I agree. Okay. Because your charges can direct into the earth through your earth wire. Okay, this one is only for metal casing appliances, which would explain the toaster question later on. Okay? Question 23, Ethel. B, I agree. Okay, your fuse should never be connected to the neutral wire. Easy? Yes, Jovia? Can? Can, huh? 25. Jat? B. D. Good. Okay, live wire should be the one connected to your switch. Okay, if I give you guys a random diagram like this, okay, I expect everybody to know that this fella is your fuse, which means this guy should always be the live wire. Clear? Your earth wire is always on top one, don't need to worry. Okay, which means the last guy by process of elimination will be your neutral wire. Are we clear? Okay, the live wire is the one connected to your switch, yeah? And connected to your fuse as well. Good. Let's carry on with the integrated questions. Okay, we only have two very, very simple ones. And then we will start on your MCQ. Okay, a washing machine is working normally. Okay, connected to a main supply by a cable. Under normal operating conditions, you have 13 amperes. Under normal conditions, Bahan, your neutral wire got what current? 13 also, right? Okay, he's not going to run out. Okay, your current is the one fella that does not decrease as you go through the circuit. Yep. Okay, what about your earth wire, Owen? Okay, your earth wire should be as useless as possible. Realize I put 0.0, yeah? 0, you won't get the mark. Clear? You will get the tick lah. Then at the front they will minus 1 mark. A bit stupid. Okay? The insulation on the mains cable is now damaged. Okay, and then your live wire touches the metal casing. Explain how the earth wire as well as the fuse prevents a user from getting electric shock. Vera? Tell me what your fuse does first. Okay, fuse melts when current flowing through flow exceeds fuse rating. How exactly does this help? Okay, this will open the circuit. Okay, and prevents excessive current from flowing into the appliance. Through the appliance. That's a better word. Are we okay? Jovia, what does the earth wire do? Are you just reading off the notes? You know right?
No, I wrote when the large current flows through the earth wire redirects current to the earth wire.
Okay. Okay, fair enough. Okay, your answer should be very similar to the notes, huh? Okay, earth wire redirects current into the what the fuck? I can't spell into the earth. Okay, by providing a path of low resistance when the live wire touches the casing. Okay, this will give you 2 marks so far because we haven't referenced the user yet. Correct or not? Okay, hence, okay, this one 1. Hence, when the user, or rather the user can touch the appliance, the user can touch the casing of the appliance. Okay, but your charges, okay, don't flow. Will not flow through. I want to say him, but let's not assume anything. Through the user. Questions? This is your 3rd mark. I break the connection, so there's no charges. And even if there were, your earth wire is there. Couple of layers of protection here. Are we okay so far? Yeah, I reckon you guys should be able to get at least the first 2. Okay, then after it's all about referencing, okay, answering the question. We want to protect the user. Next. Why is there a 3-pin plug necessary? Naomi?
As the previous block has a live wire that will help carry the current from the
Wait. Okay, don't misunderstand the question, yeah? Okay, if I'm asking why a 3-pin plug is necessary, another way to phrase the question would be, why 2-pin plug cannot? In other words, this answer should revolve around the importance of your earth wire. Why is that third plug so important? How?
because a previous block has an earth wire that helps route access charges into the earth.
Okay, but like there are appliances that got 2-pin and still work safely, right? So what is it about this toaster that makes it unsafe if I only have 2-pin?
It has exposed metal parts.
It has exposed metal parts, sure. Okay, you have your metal casing. This fella can become live in the case of a fault. Right or not? Okay, so your 3-pin plug is necessary, okay, because the toaster has an exposed metal casing, okay, which can become live in the case of a fault. Events of a fault. Okay, this is the problem. Let us introduce the solution. Hence, an earth wire will redirect current or redirect excess charges into the earth by providing a path of low resistance. Okay, this part is a bit repetitive already. Okay, but protects the user. Okay, your toaster, if you have an exposed metal casing, a third wire is obviously fucking important. Okay, so if you touch it, you don't freaking die. Again. I'll wait. Okay, plug as a fuse, explain the function of a fuse and how it's connected to the mains supply. Sichang, what does your fuse do?
It is a safety device to protect plugs from excessive current.
Okay, it protects the appliance from excessive current by
Redirecting the excess charges to
does your fuse redirect charges?
melts when there is excessive charge.
Yeah. Okay. Protects the appliance from excessive current by melting. Okay, when current flow exceeds the rating. Exceeds the current rating of the appliance. Of the fuse. How is it connected then?
It's connected to the live wire.
Okay. It is indeed connected to your live wire. Live wire before the switch. This is important. It is part of your answer. It is part of where the fuse is located. Before the appliance as well as before the switch. Questions? If not, good. Last one, the answer is 10 amperes. Any problem? Okay, your rating should be 10 amperes. Slightly higher than your operating current. Issues? Issues? Yes, no? Good. If not, okay, let's keep your practical electricity notes and worksheet. Okay, I will not be going back to this for quite a while. And let's do some practice. I'm gonna give you guys 1 hour for this. Okay, and during this 1 hour, if I see any phones, I'm taking it. I'm not fucking around here, okay? I want it to be taken seriously. Okay, there's 40 questions here. I'll put a nice clock on the board so you all can see whether you are too close to us. Selesai ya? Okay, what's up? 2, 2, 2. There you go. Selesai ya? There you go. Okay, 1 hour. Where is my clock?
What was that?
What was what? What was that? What was what?
I
I didn't see anything. Come, let's go. Calculators out, everything out. Go, go. I told you guys about this last week, huh? Okay, I said. Oh, sorry, I didn't tell you guys. Chill, man. Why are you so angry, bro? You calm down.
I'm good at maths.
Are you good at physics?
Until practical. Shut up, shut up.
Bro, since when did you learn this? No, what?
I just want to see where you guys are at. That's all. If you're a shit, then you're a shit. It's fine.
Yeah, I'm shit.
Yeah, it's fine. It's fine. I'm saying. So just calm down.
You know what? You know what's wrong.
Acceleration is changed in velocity over time.